Good day, folks. This is video number 4 in the playlist, which is on motion design application in 3D experience and in the playlist which deals with dynamics problems. It's a very simple problem from elementary physics. So we have a block that is falling from a height that's shown here under gravity, and it is going to hit the block and uh, basically bounces back or it sticks to it, depending on a few other things that we're going to talk about. In this particular video, I'm going to assume that it's a fully elastic impact. In other words, when it mm, the plate down there, it bounces back without essentially losing any energy. Therefore, the coefficient of restitution in a problem like that is actually 1. Okay. Now, here are the dimensions of the block, 0.1 meter, 10 centimeter basically, and default properties of steel are used. So if you look at the dimension of this block, 0.1 by 0.1 by 0.1 meter, 10 centimeter cube basically, uh, you multiply it by the density of steel, default density of steel in 3D experience, and you come up with about 7 kilogram. And I'm going to do it over a 4-second interval. Okay. Now, from elementary physics, we can find out when it hits the ground what the velocity of it should be, roughly 4.4 meter per second, and we know how long it takes for it to reach the ground and hit it, okay? Approximately 0.45 seconds. Now, when I do that, I will be using motion design because this tutorial was also done using mechanical systems experience with the same information, but we're going to use the motion design and motion design application, and it's going to be a dynamic over the 3-second interval. I'm going to simulate over 3-second interval, but I will do a few things. First, I use the default properties of uh, uh, impact, which are seems to be these numbers, which is not what I want because actually what I want is coefficient of restitution 1. But I'm going to show it to you with these numbers, and then I'm going to change this 0.6 coefficient of restitution, make it 1, which is pretty much what I want, show you what the result is going to be. And then I'm going to come back and fool around with this number here. So coefficient of restitution is 1, but the stiffness scaling down here, I'm going to use that default value and change it to something else and show you what happened. Okay, so let's go ahead and do that. Here is the experience. Let's go to assembly design because we have to create this thing as an assembly. So let's do the fixed plate at the bottom. So insert 3D part. I'm going to call this thing fixed plate. Fixed plate. And here's the instance name, also fixed plate. Okay, let's go ahead and make it. It's basically a plate down there. So here I'm in part design now. On that horizontal plane, I will sketch. I'll sketch a square just to make it look better. I center it at the origin, and the dimensions are 0.3 on each side, 0.3 meters on each side. Okay, so there we are. Let's also dimension this, 0.3. Okay, I'm going to exit this and then pad it in the other direction by negative 0.02. So basically, there's my plate. Okay, fixed plate. And now I'm going to insert the block. So right click, insert, 3D part. Let me call this thing block properties, block, and block. I'm going to go make it. Let's go into part design. On that same horizontal plane, XY plane, we'll sketch. The size of the block is 0.1 by 0.1. meters, which means 10 centimeter by 10 centimeters, basically. 0.1, and also this one is also 0.1. All right, exit, and then pad it by height of 0.1. Okay, there's my block. Now I want to lift this block up so that the distance between the bottom of it and the top of the plate is 1 meter. For example, and I'm going to use the compass to do that. So what I'm going to do, first of all, make sure that you're in assembly design, not part design. Assembly design, we can see that. Now grab the compass and put it, for example, on that face, okay? And left double click on the arrow, compass arrow, and make 1.1 for W. The reason I put 1.1 here is that if you take that face and move it up by 1 meter, the distance between the block and the plate is going to be 0.9. So I go 1.1 minus the 0.1 meter height of the block. That will give you 1 meter clearance between the block and the plate. So just use this left arrow and okay, close. And there we are. And when you're done, just bring the compass to where it was. There are other ways of having done this thing, but right now, the distance between bottom of this block and the top of the plate is actually 1 meter. Okay. So now we're going to create our assembly constraint. Let's go to assembly. We're going to fix the plate here. So fix the plate. It's fixed. You can see that. And that's pretty much it. We don't need any joints here. We just drop this thing down. So now we're going to go to motion design. As soon as you go to motion design, it says, should I create basically a mechanism and joints? The answer is yes. And then we say, okay. Notice what happens is that it creates a joint and there's no joint here. The only thing is a fixed part. And there's gravity involved here. The value of the gravitational constant is minus 9.81 as we want it. And that's pretty much it. So by the way, let me show you something. We go to bodies. If you look at the block, if you left double click on the block, it says that the mass of it is 7.77 kilogram. That's because I didn't assign any mass properties. When you don't, then it's going to automatically put the properties of steel, default properties of steel, and apparently the density is around 7,770 kilogram. So that's why we get the mass, the correct mass that we want. Okay. Now, if you go to simulation right now and run it, you will see that there is no contact between the block and the plate, and it's going to go through it. Let me show you here. Just to run it, it's done. And if you go to the results, for example, and say show it to me, results, it's going to go through it. Here, look. Go further down. Because the block does not actually see this display. So let's go back. We have to do more. So we go back to mechanism. There is contact here. See that? Contact, 3D contact. You click on it. It says contact between what and what. I want a contact between the block and the fixed plate. And if you check this menu here, pull down menu essentially, it uses default properties that I mentioned here. So let's run it now and see what happens. Say okay. We're going to go run it. Go to simulation, run it. You're going to see what happens. So select the dynamic step, results, animation, and oh, whoa, This is what happens. By the way, I wanted to check, make this thing 3 seconds, not 5 seconds. So let me double click on my not results, but on my scenario right here. Double click on that, make it 3 seconds. Okay, just so that you can see it, let's run it again. You can also either run it or by preview here. Look, preview. So a lot of crazy things happen because of those coefficients that you see. And then gravity, of course, makes this thing pull down. All right, so this is not correct. What we want to do is to go and change our coefficient. First of all, don't worry about friction because we're assuming that this is going to be fully elastic. We can make the coefficient 0 and then coefficient of friction coefficient 0 and then restitution coefficient 1. That's what I want for now. So we go back to contact here, make this thing 0, no friction, and make this thing 1. Okay? And then say okay, and now try to run it. So let's go to simulation, run this thing, wait until it finishes 100% complete. Now we select the result, go to the results, play animation, and let me make this thing going back, do it continuously. This is what happens. So notice that this is what it does. In fact, let me show you something here. If you plot the results and just show me what happened to the block, the vertical displacement of the block, this is what happens. Okay, so this is where it started, roughly 1.1, and then crazy things happen. So let's go back and to our coefficients and change it to this last number. We're going to change it. This last number, we're going to change it to 0.01. Okay, so go back to the contact. The only thing that we're going to do, we're going to make this thing 0.01. And then we say okay, and now run it. Wait until it finishes. Okay, select your result right here, dynamic step, and go to results, animation, and let's do it continuously so that we can see what happens. That's the way it should be, isn't it? If there is no energy dissipated. Now, let's plot the stuff. And once again, just show me the block and the Z displacement of the block and show it to me. That's the way it should be. It starts from the height of 1, okay? Or 1.1, for example, if you look at the height of the block, and then it goes back to 1.1, 1.1, 1.1, etc. If you look at, and so that agrees with, let's see now, the actual height stays the same. Now let's look at the time of impact, 0.45, roughly 0.45. So let's see now, this is the point of impact, roughly 0.45. You can see these numbers here, 0.45, 0.5, 0.45, something like that. And let's look at the velocity. If you want to look at the velocity, let me get rid of this plot. Let me look at the velocity in the Z direction. And that's the way it should be, right? Impact 0.4429. Yeah, roughly 0.429 for 0.437, etc. So you got to be careful with this contact property. With this contact properties, you can change it. I'm going to change this thing instead of 0.01. I'm going to change it to 0.1 and see what happens. So let me close this, go back to that contact. I'm going to change this thing to 0.1 and run it one more time. Simulation, run it. finished. Let's go and select the dynamic results and look at the animation first. Look at the displacement plot. Height of Z, so block height of Z, that looks good. That's fine. Okay. Let's go ahead and do it another change here. So back to that contact, we're going to change this thing to point. Remember the default was 1, it went crazy. Let's make it 0.6 and run it. So look at the animation, see what happens. And if you stop this and look at the vertical displacement, okay, these are okay, except that after a while, this is what takes place. Anyway, unfortunately, the information about this contact property is not well presented in the documentation, and so it's going to be tough to to come up with things on the first run based on insufficient information about the theoretical model. Okay, good luck.